All right, let's go back to example 1. This one is called difference in squares. Now, anytime you have a problem and there's a minus in between and you only have two things, you start with step 1, can you take anything out? If you can't and you have perfect squares with a minus in between, there's a shortcut, a formula for that. You're going to do x plus y times x minus y. Now let's actually look at that with a few problems. So you start on part A, t squared minus 36. I ask myself, can I take anything out? No. I only have two terms and it's a minus in the middle. If they're both perfect squares, then I can use the shortcut. Here they squared a t and here they squared a 6. So they are both perfect squares. So the answer to this would be t plus 6 times t minus 6. And you can check this by using FOIL. You get t squared with your first. Your outside is a negative 6t. Your inside is a positive 6t. Those will cancel out. And then last gives you that negative 36. So it did work. Now let's look at part B. First thing we want to do is, can we take anything out? In this case, we have a 4a squared minus 64. We can take something out here. They have a 4 in common. So if I take out a 4 and put it in the front, then I'm left with a squared minus 16, because 4 goes into 64 16 times. Okay? Now we're not done. We need to check and see if this will factor. So I look at it and I see if they're perfect squares. On the first one, they squared an a. On this one, they squared a 4. So I'm going to put my 4 in the front, and then this will factor into a plus 4 times a minus 4. And if we FOIL this, a times a is a squared. A times negative 4 is negative 4a. A times positive 4 is positive 4a. Those will cancel out. And then a positive 4 times a negative 4 is that negative 16. So the correct answer would be this entire thing here. 4 times a plus 4 times a minus 4. Okay, let's try the next one and see what we get. On this one, we have 16m squared minus 49p squared. Step number 1, can we take anything out? And the answer to that is no. Now I only have two things, so I want to look for either squares or cubes. Cubes is our next example. In this case, we have a squared, so let's see, are they both perfect squares? They squared a 4 and they squared an m. On this one, 49p squared, they squared a 7 and they squared a p. So I can do this. I'm going to see what they squared. It was a 4m, and then I'm going to put 4m plus 7p and 4m minus 7p. And that one will be factored. Okay, let's look at the last one. The last one is a little bit trickier. On the last one, start with what can you take out, and there's nothing. Okay, we only have two things, and they are squares, believe it or not. X to the 4th is x squared times x squared, and 81 is 9 times 9. So they squared an x squared and a 9. So let's go back and use the formula. It's going to be the first one plus the second one. That would be x squared plus 9. And then the first one minus the second one. And that would be x squared minus 9. Now the reason this one's a little bit trickier, let's look at all these. I had t minus 6, no squares. A minus 4, no squares. And 4m minus 7p, no squares. Notice I don't care about the positive ones. This only works for negative, okay? If you look at this one will factor again. The very end of that problem, we still have perfect squares that we need to get rid of. They squared an x here and a 3 there. So that will factor again. So what you do is you bring down your x squared plus 9. That won't factor again because it's positive. But this one will. You do first one plus the second one. That's your x plus 3. And then you do first one minus the second one. That would be x minus 3. Now see, now we have no squares left, so we know we've factored it as low as it will go. It won't factor anymore. And that would be your final answer.